In this lecture, we're going to start talking about the object-oriented features of Kotlin, and specifically about creating and using our own classes. So in Kotlin, to create a class, pretty straightforward. Use the keyword class. So for this one, I'm going to, through a series of lectures, create a real basic little object model where we have something to represent a book. So you have a book, and the book has chapters and some properties and different features within that. So let's start with the base one, a chapter. So if I wanted to create a chapter class, I just do class, chapter, and then in parentheses I'll go through and now define, first off, my properties. So let's say for our chapter, we're going to have, I'm going to make them all vowels for right now. We'll probably change that later. So we'll do val chapter number, and that would be an int. And let's have a val title, that would be a string, and val first page, a string, and maybe last one we'll do val number of pages, and that would be an int. Okay, so we have, real basic class here. However, I want to show you a shortcut that is what you will mostly see. So in Kotlin, one of the neat things that you can do, and it's partly just to, well, it's not partly, it's pretty much, they do it this way just to make the code a little cleaner. We can go through and do something like this. And I could do it all in one line, although I'll probably break it up more. But you make it, it almost looks like a function declaration to me. And there could be other languages that do this. I'm not familiar with them. Kotlin's the only one that I know of that does this. But you could create something like this. And what we've done here now is we've defined a new chapter class. We've defined 4 properties. And in this, it's actually going to create the constructor for us automatically. It all happens automatically. So I can come down here now and I can say val chapter 1 equals chapter. And then let's see, so chapter number it's chapter number 1. Maybe the title is in the beginning. And the first page starts on page number 1. And let's say number of pages is, it's a 10-page chapter. So if we run this, nothing exciting happens. Oh, I've got a typo somewhere. Oh, first page. Okay, up here you can see I made a mistake. First page is an int, not a string. So nothing exciting happens, but what we have done here is we have created an instance of the chapter object. So we have one called chapter 1. And of course we could do val chapter 2 equals chapter 2 once upon a time, and it would start on page 11, and then maybe it runs for 5 pages. Okay, so there's the basics of it. One of the things that you'll see pretty frequently is when you're creating classes, and we'll probably talk more about this as this course goes on, but when you're defining your classes, a lot of times you end up defining classes whose only job is to hold data, is to group data together and hold it. And that's really all this one does, right? There's no real functionality here. It's just to hold data. And this is so common in modern app architecture and modern software development that it actually has a keyword that we can actually use called data. And when you do a data class, I'm not going to get too much into it in this course, I don't think, maybe later a little bit, but it actually generates some utility features behind the scenes for us. So in this case, if I said data class chapter, it would also create a function called copy that would create a duplicate of this object with the same data, would be one example. It would also create a function called, it automatically creates a function toString. So I'll show you what I mean by that. Let's take this out actually. And let's go down here and say print line, and let's print chapter 1. So if I run this right now, and this is just a normal class, what do we get? We get chapter at, and we get a memory address. Right? So if we try to print out the class, right? Or this, sorry, chapter 1, the instance of this class. All we're doing is getting, here's a memory location, right? Because I don't know if you guys have done any C programming. If not, I always actually think it's a good idea to have some familiarity with C because you learn about pointers. And an instance of a class is a pointer to a memory location. And that's really sort of what we're getting here, is getting a little information about where that is in memory. But if I come up here instead and say data class, and now we run this guy, we actually get a nice two-string representation. So what happened here is print line, I said chapter 1, and if you remember, print line will automatically try to get a string representation. It will call toString. So when it calls toString, because I said data class, it automatically created a toString function that just takes all of the parameters and the values and just spits them out. So again, not terribly useful in what we do every day, but it's there. And so there's a couple different things that data class do for us. So generally speaking, what you'll want to do is, if you're creating something and it doesn't really have a lot of functionality, it's primarily there to hold data for us, then do it as a data class. It creates a couple convenient functions that you may later find useful. And there's no real cost to doing this. Okay, so let's move on. So within this data class, some of the things I also want to talk about, and these aren't specific to data classes, but what we've done up here is we've created a new class, and in here I can within the model itself I can create more. So for example, we don't have a property for last page. Notice, right? I have first page and I have number of pages, but we don't have one for last page. So if that's information that I wanted to store, I could have done this. I could have said, comma, val, last page as an int. And then now we pass in the last page. But as often is the case, we have a property that we might want to, right? Let's say we need to know the last page of a chapter in our program, but we already have all the information we need. We know the first page, and we know the number of pages, so therefore we know what the last page is. I don't need to store that, right? I can compute it. And if you've done object-oriented programming before in other languages, the first thing you would probably think is to create a function. And it wouldn't necessarily be wrong. So we could create a function last page, and it returns an int. And last page would be just one line of code. Return first page plus number of pages minus 1. And yes, we could have just done this without parentheses, but I like doing this because I think it makes the code a little bit more clear to read. And again, you're going to hear me say this a million times. Good code, number one is always going to be it works. It does what it's supposed to do, right? That's the most important thing, obviously. The second most important thing, in my opinion, with doing this for a living for 30 years, is that the code is easy to read. So anytime I can do something in my code that I can structure it in a way that I think is going to make it easier for myself or other people to understand what this code is doing, I'm going to say that's the right way to do it. So to me, this makes it easier to understand, because if you didn't think about it, you might have just done first page plus number of pages. But if the pages, it's actually always minus 1, right? Because if we started on, let's say the first chapter is only 1 page. So it starts on page 1, it's 1 page long. What's the last page? Well, the last page is still the first page, right? Because chapter 2 would start on page 2. So it's always going to be number of pages minus 1. But if I just said first pages plus number of pages minus 1, it may not be clear. But I think when I do this, I think the logic becomes very clear, or at least more clear, easier to grasp. Now, in the real world, you would also want to put some kind of comment explaining why. But you guys don't want to sit in a lecture and watch me type comments any more than I have to. So we have last page, and this would be fine, right? So we could do something like println chapter 1 dot last page, and we run it, and it works out great. Last page is page 10, is what I would have expected. So that's all good, and it can be a function, but the thing about this is it really a function? Right? It's kind of a property, right? It's a property of the chapter. And again, these get a little, arbitrary somewhat, right? The line's a little blurry between when is something a function versus when is it a property. Traditionally in languages, properties was data that we stored, functions were operations on the data. But that definition has evolved where properties are really truly that abstract concept of a property, something that defines this object, right? The features and the things that define it. And I would argue that last page is actually a property. So we can fix that. So instead of fun last page, I can do, in this case we'll make it a val because it's going to be read-only. So val last page, and it is an int. So if I just stopped there, what I will have done is defined a new property. And what I could do, and let's go ahead and comment this one out. Oh, the shortcut for comment, I guess, doesn't work in this editor. No problem. Okay, so we could do that. But I also could do this. So we could define init. And what init does, oops, come on, crazy editor. So what init does, this is a special function. Notice there's no parentheses. But it is a special function that will run immediately after the constructor. You remember the constructor automatically gets created with this up here. So in the init, I could say last page equals first page plus number of pages minus 1. And for some reason, I always keep capitalizing that. And so now if I run this code, we should get the same, oop, I mistyped some, oh, sorry. We made it a property, so I'll remove the parentheses, right? So it's just chapter 1 last page. And now we should get the same answer of, oh, mistyped page somewhere. I'm dying here. There we go. And we get 10, so we get the same thing. So that's what init does. So init is it's like a very, very specialized function that will run after your constructor. And you can use it to do things like this, default values, do something, some data manipulation, whatever you would need to do. So it's similar to a constructor, but it doesn't take parameters. It's just there to operate on parameters. And this is the way Kotlin kind of gets around forcing you to create a constructor. You still can create constructors, but oftentimes you see this. People will define their properties up here. Those automatically become a constructor, and then anything they need to do with them, you do them in init. And the thought is that this is a little cleaner. And we'll see more examples of why this is cleaner as I get through this lecture. Or the next lecture, maybe. We'll see. So this is another way to do it. Okay, let's close this to give us some more room. I think you understand this enough. I'm going to go ahead and delete it. But this isn't the only way. So another way we could do it, and what I would say is this is the way that most people who write Kotlin on a regular basis would do it, is I can go through and make a property a computed property, meaning that this property actually behind the scenes runs a function. And I do that just by, on the same line, just adding in get, and then a code block, as we talked before, a lambda, or a closure, or whatever term that you're using. So here now I can just treat it like a function. The function will turn an int because it's the get for this property. So now let's return first page plus last page minus 1. So what have we done here? Let me walk through it one more time. We're creating last page. It's a val, so it means that it has to have a value, right? And I've defined a get parameter. Notice I didn't define a set. You can define a set, but in this case, it's read-only, last page. We define a get, and with it, we return the first page plus the last page minus 1. So what happens is when you say chapter 1.last page, it runs this function. And this function returns an int because it is associated with this property. So if we run this code, unless I've made a typo, which of course I did somewhere, I gotta figure out where my typo is. Oh, huh. Did anybody catch that before I did? So I was referring to the property inside the code that gets the property. So we had basically a Stack Overflow, meaning it just kept calling itself recursively until we ran out of memory. Not good. So let's try that again. Oh, I can't type number of pages. There we go, 10. So we get the same thing. So 3 different ways of doing more or less the exact same thing. And this is the part and I hate the term, people overuse the term art, quite frankly, way overuse it. When really what they mean, I think, is creativity. And I won't get off into the philosophical discussion of the difference between art and just simple creativity, but I'm going to use the term creativity. So here is an opportunity in code. There's always an opportunity in coding to be creative, but we want to be creative not for the sake of creativity, but you want to be creative for the sake of clarity. So in this case, I showed you three. Actually, we could have just made it a parameter, made whoever created the object create, right, define the number of pages, and hope that the last page, we could have asked the creator of this object to pass in the last page, and then maybe validated that these numbers all synced up. That was one option. Another option is we could have just defined a function. Another option is we could have defined a property and then set the property in the init. And then the fourth option I've shown you is we create a computed property. All four of those work perfectly fine. Although I'd argue the first one is not a good solution, but the last three certainly are. So what you have to do is, and again, this is your opportunity for your own style and your own creativity, is to kind of think about what is the program doing? What is it I want it to do? What's the most reliable way that I can put this in place? What's the way that makes the code the clearest? What's the way that allows me to do any future enhancements I think I might want? But also I don't want to overcomplicate it in anticipation of something in the future. That's more of a software engineering concept, so outside the scope of this class. But these are the things that you ask yourself, and this is really where the creativity comes into play, is really thinking these things through, thinking about the different options. Don't just sit down and do it the first way you think of. Really put some thought into it, because one, it will lead to better results in the short term, because you've thought it through and you've very purposefully chosen your path on how you want to do it. But also in the long term, thinking about these things enhances your knowledge of them. And what you'll find is that you may understand the concept, but as you think about how you apply it in different specific places and different specific programs you write, the depth of your understanding of these concepts will grow and expand. And so it's really by forcing yourself to think about this stuff is what takes you, kind of to that level of true competency when it comes to software development. So writing code, it very much is a creative process, because you have lots of options, and how you want to structure and do things is really going to be up to you. Okay, so you know what? I think there's still a lot more to cover, but I'm trying to keep these videos from getting too long. So we're going to stop this one here, and we'll pick it up in the next video.